Okay, hi. Once again, welcome back as we continue on the topic of coordinate geometry. Okay, I hope you have understand well on the concepts on the first part of the topic where we have learned about how to find the gradient of the straight line. So moving on to the second part of the notes, okay, I am going to touch on how to determine the length of a line segment. Now, to find the length of the line segment, okay, you must have 2 points to join them together. So in this case, let's call it A and B. Okay, so any line, you must always have 2 points. Okay, and in this case, we will call them A and B. Okay, and you know that for each of these coordinates, there will always be a x coordinate and a y coordinate. Same for B, where there's an x coordinate, we call it x2 and y2. Okay, now earlier on we have covered on the gradient of the straight line, which I hope you still remember the formula, which is given by y is equal to y2 minus y1 over x2 minus x1. But for the length of the line segment, this is the equation, the formula that you have to memorize. Okay, so the length of the line segment is given by, okay, the square root of bracket x2 minus x1 close bracket square plus y2 minus y1 close bracket square. And the length is to be written as units. Okay, very important. Okay, if you were to write in cm, the answer will be wrong. So please write all your lengths of the line segment in units. And of course, if the length is unit, then the area will be unit square. Now, under what circumstances will we be tested on area? So for example, if I were to give you 3 coordinates on the graph, okay, and I give you each of the coordinate points, and I ask you to find the area of the triangle, then of course it will be half times base times this height over here. And because on the graph all the lengths are represented by units, so the area of the triangle will thus be unit square. Okay, let's continue. Now let's try question 8 over here. Okay, find the length of the line segment joining each of the following pairs of points. Okay, I'm just going to go through part A. So you have 2 points A. Okay, as usual, please name them x1 y1 and x2 y2. Okay, and so based on this formula on top, you will then apply into these 2 coordinates. So the length of AB will be equal to square root, okay, of x2 is 6 minus 4. Do you see this? It's 6 minus 4, which is 6 plus 4, bracket square plus bracket y2 minus y1. So it's minus 5 minus 1 bracket square. Okay, so you will then evaluate what is inside. Okay, so 6 plus 4 is 10, 10 square is 100. Okay, minus 5 minus 1 is minus 6, square is 36. Am I right? Yes, 36. Okay, then you square root. Sorry, this is a plus and not a times. Okay, now then the answer will be square root 136. Okay, you can press using your calculator and you can write it in 3 sig fig, and then your answer must be in units. Okay, understand? So please be careful, especially when you are minusing off the x and the y coordinates, because when you have a negative sign at the back, when you minus and minus, it ends up being a plus. Okay, so this is very common, like for example the x part, 6 minus 4, it becomes 6 plus 4. Okay, now let's move on to the next question. So for this, please work out the answers and show it to me during the next lesson. Now, given that the coordinates of the points A and B are minus 3, 2 and 1 minus 6 respectively, find the coordinates of C that lies on the y-axis such that AC is equal to BC, okay, and hence find the area of the triangle ACO where O is the origin. Okay, you may be thinking, wow, I'm so overwhelmed by this question. Okay, it seems a bit complicated. Now let's break it into smaller parts. Okay, now we know that the coordinates of point A and B is minus 3, 2 and 1, minus 6. So straight away, what I will do is I will try to, write down this is x1, this is y1, okay, x2, okay, sorry, oops, and y2. Okay, so sorry, this is x. Okay, so I have another third point, which is point C, that lies on the y-axis. Now if you were to draw a graph like that, and you know this is the x, this is the y-axis, any point that lies on the y-axis, you will realize that the x coordinate is always a 0, but the y I will not know. Okay, but I know it's somewhere along the y-axis, but I know that the x coordinate will definitely be 0. Okay, and then AC is equal to AB. So this is your third coordinate, x3, y3, for example. So if the length of AC is equal to BC, so I call this point C, then you can then write, the length of AC will be square root, okay, let's look at just A and C. Okay, so y minus 2, y2 minus yes, y2 minus correct, y2, okay, y2 minus y1 square plus, what's your x? Your x is 0, minus 3, so it's plus 3 square, okay, equals to square root. Okay, now you write for BC. So B is this, right? So minus 6, which is your y2, minus away your y square plus, then what do you have here? 1 minus 0 square. Then your next step should be removal of your your square root, where you are just left with the inner parts. Okay, then you expand them and then you solve for your y coordinate. So once you get your y coordinate, you then sub in into this and you will know what is your point C, the coordinates. So when you write your answers, find the coordinates of point C. Please represent the answer in this format: something, comma, something, close bracket, where this is your x and this is your y coordinate. Okay, hence find the triangle, area of the triangle ACO, where O is the origin. Okay, so please go and, so what you have to do is please draw out this triangle roughly on the plot. Okay, like minus 3 ACO, right? So minus 3 and 2, there's a point A here. Okay, and then you have to find your point C. I don't know what is it, but let's say it's somewhere here. Okay, I do not know, you have to work it out yourself. Okay, and then the origin. So this makes the triangle. So how to find the area of the triangle? You have to use half times base times perpendicular height. Okay, this is not that straightforward, but I want you to spend some time to try to work out this problem. If you cannot, don't worry, next lesson we will go through together for this question. Okay, so attempt yourself as usual. Okay, these are the more fundamental ones. You just have to find the length of AB, okay, and then you have to find the length of GH. Okay, and remember to write your answers in units. Okay, I don't want to see cm on your answers. Okay, So this is the same. Okay, you're given two coordinates here. Then you have to find another coordinate point R that lies on the y-axis. Okay, so when it's on the y-axis, you should know that your x coordinate of this is a 0. And if it's on the x-axis, then of course the y coordinate is 0. Okay, so okay, these are the more tricky ones. The distance between these 2 points is this. So this is your x1, your y1, x2 and y2, and this is your distance in units. So equate them together using the equation and you'll be able to find the possible values of t. Now for this, okay, 3 vertices that they provide with you, you have to show that this triangle is a right angle triangle. Okay, so let me give you a tip. If it's a right angle triangle, it should fulfill the Pythagoras theorem. Okay, I hope you still remember what's the Pythagoras theorem. Basically, it's a square plus b square is equal to c square. Okay, now this is isosceles triangle. Okay, so please go and think about what properties does the isosceles triangle have. By drawing this, I'm already giving you a very big clue. Okay, so yes, now I want you to complete until question 14 so that when I'm in class we will then go through all these questions and recap on your understanding of finding the length of a line segment, which is determined by this formula. So if you were to apply this formula in all the questions in this section, I believe you should be able to do all these questions without much problems. Okay, so with that we shall end the lesson today. Thank you.